In the earlier classes, we have discussed the first order correction to energy, first order correction to wave function. Now, in this class, we are going to discuss second order correction to energy. So, the second order correction to energy can be found by using the second order perturbation. So, this is the second order perturbation equation, that is h power 1 psi power 1 plus h naught psi n power 2, which is equals to en power 2 psi n power 0 plus en power 1 psi n power 1 plus en power 0 psi n power 2. So if you write it, this equation 1, uh, states as ket states, we can represent like this. So the equation will become h power 1 psi n power 1 plus h power 0 psi n power 2, which is equals to en power 2 psi n power 0 plus en power 1 psi n power 1 plus en power 0 psi n power 2. So if you multiply this above equation with unperturbed state that is psi n power 0, so the equation will become here the inner product of the bra the bra of psi n power 0 into h power 1 into ket psi n power 1 plus psi n power 0 bra psi n power 0 h power 0 psi n power 2 ket is equals to en power 2 and written outside, and the inner product of psi n power 0 plus en power 1 inner product of psi n power 0 and psi n power 1 plus en power 0 inner product of psi n power 0 psi n power 2. As we can observe here, in the RHS, in the LHS, you can observe here we have the function that is bra psi n power 0 h power 0 psi n power 2, isn't it? So as we know, h naught is what? H naught is Hermitian, isn't it? So h naught is here Hermitian. So we can write, as this is Hermitian, we can write h naught psi n 0 is equals to en naught psi n power 0, isn't it? So in the same manner we have written, so as h naught is Hermitian, we have written like this, that is en 0 into inner product of psi n 0 and psi n 2. But if you observe here, this is the same state and this is the same state, but those are in a different order. So the inner product of different functions, different order function, will be equals to 0. The inner product of different functions or different order functions is equals to 0. So this term in the LHS, the second term in the LHS will vanish away. And if you observe the other terms here, psi n power 0 and psi n power 0, that is inner product of psi n power 0 having the same functions, the value will become 1. This is the normalization condition, isn't it? So the inner product of psi n power 0 will be equals to 1. And the second term, if you observe, this is psi n power 0 into psi n power 1. Psi n power 0 into psi n power 1. So these are different functions, so the value will become 0. The third term also, the different functions, there are the inner product of different functions. That's why the value will become 0 here. So here the second and third term will vanish away. And we are remained with only one term in the RHS and one term in the LHS. That is first terms of RHS and LHS. So what are the terms we are left with? We are left with the first term, that is psi n power 0 h power 1 psi n power 2, as we have discussed that en power 0 into psi n power 0 psi n power 2 will become 0. So on the RHS the value is en power 2. So en power 2 is nothing but energy correction to second order, isn't it? So correction to second order, that is second order correction to energy, that is given by psi n en of 2 is equals to psi n power 0 h power 1 and get psi n power 1. Let us consider this as equation 2. If you observe here, you have the value of psi n power 1. Here it is unperturbed state, unperturbed wave function. This one is perturbed wave function, first order correction to perturbed wave function. in the earlier class we have seen that psi n power 1 is, we have found the psi n power 1 values. So that is the first order correction to wave function. So we will substitute that value in this equation. That is psi n power 1 is equals to summation over m bra phi m into h power 1 phi ket phi n by en power 0 minus en power 0 into ket phi m. So we will substitute this equation at this place. If we substitute that, the equation will become like this. So substituting psi n power 1 value in equation 2, so we will get, that is summation over m bra phi n h power 1 into inner product of bra phi m h power 1 ket phi n by en power 0 minus en power 0 into ket phi m. Here we know that psi n power 0 is nothing but phi n, because it is unperturbed states we have considered. These are what? Unperturbed states. We can write phi n or psi n power 0. So we are writing as phi n. So the equation will become here. The equation will become phi n, that is h power 1 phi m. So this is phi n h power 1, and this is phi m we have multiplied, and phi m h power 1 phi n. So by en power 0 minus en power 0. Here we can write it as a modulus square for these two, because this is bra in first term, but here it is in ket form. So it is kept in first equation, first term, and here we have bra phi m. So we can write it as modulus square. So en power 2, even en power 2, that is second order correction to energy, is equals to summation over m modulus of bra phi m h power 1 ket phi n whole square, that is modulus square, by en power 0 minus en power 0. This is the second order correction to energy. So here the second order correction to energy is nothing but, just remember second order correction to energy. If the question comes, you just remember you have to find En power 2. En power 2, that is second order correction to energy. So for the second order correction to energy, we need perturbation equation of second order. Second order perturbation equation is what? This is the second order perturbation equation. So after finding this equation, after writing this equation, you need to write in the form of kets, and you have to multiply with psi n power 0, and you rearrange the terms, and you will get this equation, where you will find psi n power 1, that is we found in the earlier class, that is first order correction to wave function. You just need to substitute that value, so that you will get energy correction to, sorry, second order correction to energy. So I hope you understood the class. Thank you for listening. Please do subscribe to my channel.